lesson, we're going to talk about how to simplify equivalent expressions. So the first thing we want to look at is the essential question. How can properties help to write equivalent algebraic expressions? And we're going to be using the properties that we have looked at in previous lessons to help us simplify these equivalent expressions. When addition or subtraction signs separate an algebraic expression into parts, each part is called a term. And this is your first word in your vocabulary today. You also have a coefficient, which is the numerical factor of a term that contains a variable. The term without the variable is called a constant. And like terms are terms that contain the same variables. Go ahead and pause the video, write all of these down in your notes, and then when you're finished, continue. I'm going to first show you one expression that will help you identify the difference between like terms and just general terms and so on. So if you look here at this first expression, we have a 3x plus 7 plus x. And I have shown you that each of these terms is separated by an operation sign. So that's how you can decide how many terms there are. Also in the red here, I decided that the variable x represents like terms. So we have 3x and x, which are like terms because they have the same variable. Okay? Let's take a look at another expression here that we're going to look at, and we're going to go ahead and label each part of this expression. I've already decided to label the terms for you, which we have a 4n, a 2n, and a 9. First, I'd like us to identify the like terms. Now remember, like terms are any term that has a similar characteristic, whether it has the same variable or maybe it's just a standalone number. In this case, in this expression, we have 4n and 2n, which are considered our like terms because they both have the letter n. Next, I want us to identify the constant. And remember, the constant is a number or a term without a variable. And the last one over here is a coefficient. There are technically two coefficients within this expression, but I just identified one of them for you so you could see that, remember, a coefficient has a number and a letter. We're first going to start simplifying expressions with one variable. And how to do this isn't as scary as it may look. What we want to do is use the different properties that we talked about to simplify these expressions. So there are no two like terms and there are no parentheses within each expression. So the first thing I want to do is simplify this expression 4 times 6x. And remember, the parentheses mean you're using multiplication. We don't know what x is, so it's going to stay with our 6. And we don't care what it is right now, but we're just going to keep it there because it is a coefficient with the number 6. Okay? You can use the distributive property. Technically, we're just using the associative property. But what we're going to do is we're going to multiply 4 times 6x, which will give us 24x. This is how you simplify that expression. We still don't know what x is, remember, so it doesn't matter what it is. It's just going to hang out there with our 24. Let's look at this one right here. We have an x plus an 3x plus x. We could think, what property is this? Well, it could be either, really. I would think it'd be the commutative property because we don't have any groupings within this one. But that just states it doesn't matter what order you add them in. Remember, you'll still get the same value. The next thing we want to look at, is there any like terms within this addition expression? Yes, we have an x, an x, and an x. So all three of these are considered like terms, and we can combine them. One thing to remember is that if you just have a variable all by itself, you can put a number 1 in front of it, and it'd still only equal 1x, right? Because there's not 2 sitting there, there's just 1. So now you can see this better as an addition problem. You're going to take 1 plus 3 plus 1, go ahead and write back in your x's so you don't forget them. But really, that's all you're doing. So when you add these all together, you will have 5x. And you have simplified that expression by combining like terms. Okay? We can go ahead and simplify with 2 variables as well. The first thing we want to look at is what kind of property is this telling us? What does it represent? Well, I would say commutative property only because it has some groupings, which states it doesn't matter what order we group it in as long as it's still grouped. So the next thing we're going to look for are like terms. Okay, 14y and 22y are like terms. And we have x all by itself. Okay, our operation is addition, so we're going to combine our like terms. So we're going to add 22y plus 14y, which gives us 36y. And since we can't combine anything with x, we're just going to add it in to the expression. So here is an equivalent expression to this expression, just simplified, combining like terms. We can simplify also using the distributive property. So if you rewrite this, so you can see it, you're going to distribute this 4 into the 2x and to the y. So it's very similar. We go back to that very first problem we did, where we take 4 times 2, which is 8. We bring the x with it because these go together, they're friends today. And then we're going to take 4 times y, which is just 4y, because we don't know what x or y equal, so they're just going to stay as x and y. This is the simplified version of the expression using the distributive property. Last thing I want to show you today is we're going to factor an expression with 2 different variables. We're going to use the SOC method, but I want you to not let those variables bother you as we're working through this initially. So I'm going to rewrite my 2 terms here. Okay, I'm going to set it up using the SOC method. Remember, the number right here on the outside will be the number on the outside of the parentheses that we create. Okay, so we want to think, what is the largest number I can divide 27 and 18 by? I picked 9. Okay, 27 divided by 9 is 3. 18 divided by 9 is 2. Okay, now, one thing that you are going to get confused on, but maybe not, since you're listening very well, you need to just bring down your variable. We don't know what it is, it doesn't matter what it is, but it stays with the simplified terms there. Okay, so just bring it down, keep it with it. Now I'm ready to rewrite this using the distributive property. So we'll have 9 on the outside, 3x in the middle, 2y at the end. This is a simplified version of this expression, except we factored it using the distributive property. Once again, the SOC method never failed us. I want you to go ahead and try these 3 guided problems on your own. The first one says to simplify 3x plus 9y plus 2x. You're combining like terms. In B, you're going to simplify using the distributive property. And in C, you're going to factor like the very last problem I just showed you